Energy is crucial for human progress. It also offers us some of the hardest challenges in search for sustainable development. Our world now has an unquenchable thirst for energy. Today, half the world doesn't have access to grid-connected electricity. A World Bank study predicted that world energy use will double between now and 2030 as the population grows from 5.3 billion to 8.5 billion. Secure supplies of energy at stable prices make development opportunities possible and are a key ingredient in stable economies and international relations. While we sometimes tend to associate fuel difficulties with the more fragile developing countries, mature economies are just as much at risk. The United States, for example, will import more than 60% of its oil by the turn of the century. By this time, OPEC countries will control 70% of world oil production. This is more than in the early 70s energy crisis. Imported fuels are vulnerable to international currency and political changes. And of course, the cost of imported fuels have an adverse effect on countries' balance of payments. There is increasing concern about the environmental costs which energy generation creates. These concerns also lead to financial uncertainties as the move towards polluter pays gathers speed internationally, inexorably raising the cost of traditional fuels. Part of the answer will lie in the world's oceans, which cover 60% of the surface of our planet. These oceans represent a huge untapped reservoir of clean and renewable energy. The ability to harness the power of the oceans will give us an inexhaustible source of energy to drive us into a sustainable future. The Osprey project has developed the enabling technology to access this resource in an economically viable way. Eco-efficiency now makes good business sense. Osprey stands for Ocean Swell-Powered Renewable Energy. The power plant sits on the ocean bed in about 16 meters of water. Above the water level, inside Osprey's collector vessel, there is an airspace. As the swell of the ocean rises every few seconds, it also rises inside Osprey, pushing the air above it up and out through the air ducts in the roof. The action is like a large water piston. As the swell falls, the water level in Osprey also falls, forcing air back in through the roof turbines. It's as if Osprey is breathing. As Osprey breathes in and out, the air passes through Wells turbines. These are designed to turn in the same direction no matter which way air is flowing through them. The turbines rotate generators to provide electricity, which can either feed into a national grid or can be used locally to provide power. The Asian Development Bank has estimated that demand for water in Asia alone will double by the year 2025. In some areas, Osprey will be linked directly to desalination plants to provide local drinking and irrigation water. A single Osprey has an installed generating capacity of 2,000 kilowatts. The optional addition of a wind turbine adds another 1,500 kilowatts of capacity, making a total of 3,500 kilowatts, enough to power a small town. In many places, however, Osprey will be deployed in arrays, where they become more efficient at capturing energy. In addition, the water behind an Osprey reef will be calmer, giving Osprey a key role in self-financing coastal protection or harbour developments. Here, in our Scottish base, we have an experienced team of engineering scientists and a suite of research laboratories dedicated to continuous development and support of marine power technologies. The Osprey project has provided the additional information necessary to design modular shoreline stations called Limpet, in collaboration with Queen's University Belfast. The Limpet has been developed for shoreline installation, each unit having an installed capacity of between 500 and 1,000 kilowatts. Applied Research and Technology also provides full consultancy services to potential users, from wave resource assessment, electricity productivity calculations, and environmental impact studies through to full turnkey project management. As we considered the environmental impacts of the Osprey project, it became increasingly clear that there were a large number of positive benefits from our fundamental development work. Once in place, it acts as an artificial reef, providing a superb aquatic habitat and breeding ground for indigenous fish, as well as enabling aquaculture activities such as shellfish farming to take place. There are a wide variety of development opportunities associated with the Osprey. While this project may operate at macro level, offering global benefits in terms of energy and sustainability, much of its attraction is that it also carries substantial benefits at micro level, helping individual coastal communities. Construction of Osprey involves standard fabrication techniques of the sort widely used in the ship and coastal engineering industries. Osprey units can be constructed at virtually any ship or coastal fabrication yard, allowing the local community to benefit fully from the economic spin-off during construction. Lead-in times are typically in the range of months, so the time from build to revenue is short. Osprey can be used to tackle specific local issues, such as shortage of drinking water and coastal erosion, while promoting new and exciting local development opportunities such as aquaculture and self-financing boating marinas. There are many benefits from local ocean power generation: competitively priced local power production, short time from development to power production, simple local construction, minimal maintenance, potential for local economic development based on sustainable energy production, creates an artificial reef for aquaculture, harbour development and coastal defence, environmentally benign structure and power generation, simple to decommission. There is both a large and growing demand and an enormous resource to supply. It would be unfair to say that the power locked up in the oceans is limitless, but there are certainly massive winnable resources out there.